courses. And so you can click on this. It's totally interactive, and you can go all the way down to the atomic concept level. So this student is about 10 points above the mean in her math course. And you can set this report any different way you like, but basically the bar indicates what her proficiencies are on average in all of math. The line indicates the historical average of all students who've ever taken the same course. And the administrator can set that to be just people in the same class or the entire country or anybody in between. All right, let's click and see what happens. So she's a little bit advanced in math. Let's see why. Well, it turns out she's really strong at algebra and geometry, and she's not so strong at, she's at or slightly above the mean in everything else. Let's keep drilling down. Why is she so strong in algebra? All right, no smoking gun here. She's strong at algebra across the board. These are all the subcategories. And I can drill all the way down to the concept level. At any given point in time, if I want to launch the learning content on something I forget or think I'm weak at, I can just click on that and launch the learning content. All right, let's see. Let's take a look at verbal. She's a little weak here. And again, this is just the data side of adaptive learning. This isn't the actual adaptive learning itself. I'll show you that in a second. So she's about 12 points below the mean in verbal. Let's see why. All right, well, that's pretty interesting because she's actually at or above competency in most of the subcategories in her English class. She's just really weak at a couple of them. So I want to spend, if I'm her student, if I'm the student or I'm her parent or her professor or tutor or what have you, I want to be able to drill in here and figure out exactly where she can spend her time. All right, and this will go all the way down, as I said, to the atomic concept level or any level. You can stop anywhere in between. All right, so how does that translate to adaptive learning? Well, now we know what the student knows, and we know it down to the concept level, so we know what to show her every single day. Let's optimize her learning graph. Maybe there are 3,000 concepts in her math course, from the most high level to the most granular. Maybe there's a few hundred, so fewer, but much bigger concepts in her verbal course. Let's optimize her learning graph every single day. Let's show her the stuff that she's weakest at that's the most important. If the professor wants to push certain content to her, make sure she sees that, the professor can do that, and then Newton will optimize around the edges. All right, so here's her homework. This is the optimized list of all the stuff that she needs to do, right? So we show her the top 5 concepts that she should do, the most urgent concepts in each course. Math, verbal, critical thinking. You can view all of them if you want. We found through trial and error that students don't like it when you show them everything that they're bad at. So we just show you the top 5, and you have to kind of click to view more. All right, so XY plane is literally the most important thing she can do. Today, let's click on that and see what happens. She gets some content in XY plane. Now, everything in Newton is linked, so you can link to any other concept ad infinitum. You can link to everything if you just forget what it is and you want to check it out. Obviously, with next generation ebooks, you get the power of rich media. And I can hear him, but you can't. He's talking about the XY plane. So you got maybe 15 minutes of content here in all, text and video and rich media. And we can actually figure out how students learn best. We can figure out, well, this student learns this concept best with text or with video or with a blend of text and video or with other media, right? So Newton can figure out not only what to show you, but how to show it to you. We can figure out you learn math best in short bite sizes, no more than 15 minutes for triangles. We can give you an hour of biology, right? Or if we give you a blend of media in math, text and video and games, we can extend your time window to 30 minutes. Per bite. We can figure out you learn triangles best in the morning. You learn Pythagorean triangles best between 8:13 and 9:42 a.m. Right? So that's the kind of data mining we can bring to our adaptive learning platform. So what happens, I just learned about 15 minutes of content. I'm going to have, now one of the side effects of Newton is we can bring the power of ETS or ACT quality adaptive testing to basically any of your own practice questions, because we're basically norming all of your own content for you, just passively while students do it. So I just did three practice questions. They were adaptive, so they were very well suited for me. Adaptive testing yields an incredible amount of information per question, much more than linear testing. And of course, as you'd expect, I got all 3 of them right. And as you'd expect, XY plane is no longer in my on the top of my list. Now you can view this any different way. This just happens to be our one form factor. You can make it look like a textbook if you want. If you click on that textbook mode button, it just makes it look like a textbook. For students who just want it to look like a textbook, it's the same content. Here's the video guy again. And unlike traditional textbooks, of course, you got rich media. You can also dynamically generate content in real time. So let's say I've got, here's the end of my XY plane section. Right before I'm going to start studying slope of a line, I'm going to answer a question, and boom, it just generates some content there in real time. In that case, an explanation. If I go to verbal now, you'll see that I've got a little bit of content on active voice versus passive voice. One of the things that printed textbooks can't do is differentiate how much content to show students. Active voice is something that most students can get in about, with just basically a clear example, basically a paragraph or two worth of content, a clear explanation, a couple of examples. But about 10% of students, especially students for whom English is a second language, need a lot more content. You know, I got both these questions wrong. If I go back to my list, I'm going to see that active voice and passive voice is still at the top of my list. I got both these questions wrong. And as I said, about 10% of students need more content on that. And if I click again, I'm going to get a lot more content. So here is an example of Newton probably didn't have a lot of information on me about how I'm going to do an active voice versus passive voice. And it tried the default bit of content. It didn't work, and it's already beginning to learn about me. It's trying a bit more. So now he's talking about active voice versus passive voice. And so, you know, printed textbook solves that problem by giving everyone 4 paragraphs of content, where maybe, you know, 90% need 1 paragraph and 10% need 12 paragraphs, right? So that's an example of, and then active voice versus passive voice is gone. So that's basically an example of concept level, proficiency level, atomic concept level adaptive learning. Now, a couple of the other features we have here that are pretty exciting, some engagement features. So, you know, once you put content online, let's just not put it there in a printed format. That's silly. Let's use all the best practices and advantages we've learned from the web and from usability and from computer games. You know, so, you know, kind of just that one more turn addiction you get from great strategy games. Let's bring some of that to education. You know, so you've got all these subcategories here, these grayed out ones that, gosh, if I just do one more, you know, module, 15 minutes on circles, I'm going to get this complete. I get to color it up. It's going to go up here. Once it becomes a full-on badge, I can share it with friends. I can brag about it. I can post it to Facebook or anywhere else on the web. You know, it becomes an object that I can do things with. Or my competitive parents can brag with each other about how I'm doing. So, you know, these kinds of basic engagement features prolong time on task. Newton can prolong time on task in other ways too. By measuring your click rate, we can figure out stuff like this student consistently, her click rate falls off a cliff at the 18-minute mark on this concept. You know, so let's pull it from her after 16 minutes and always pull it from her right before she's about to get bored of it. Some other things, now here's a feature we haven't built yet that we're really excited about. You can enter a question, just type in a question in Newton, and then you can go find the concepts that it's tagged to, right? You can either search for them or you can find them inductively. And then you can basically say, Newton, go find me the answer. And Newton will just go find everyone else in the system. So right now, if you want to self-tutor, right, if you want to find some help for yourself and your student, you're basically going to go post a question to a bulletin board, and you're going to get 30 responses back, and most of them are going to be garbage, and you're not going to be able to tell which one is good and which ones are garbage, right? So we can solve that problem by creating an intelligent social tutoring system, and this is some technology we're beginning working on this year. So Newton can basically take your whole community, like the ASU community that we're beginning to work with now, and we can say, you know, just go, you know, here's my question. I'm going to go tag it. Now just go find me an answer. And then Newton can, before we have to go get an ASU tutor, which is not a very scalable solution to do it, we can try one more thing, which is just go ask the community of other students. And we can go find a population of students who definitely know the answer to your question. They are masters of those tags, right? And we can find people who learn, we can subdivide that into a group that learns similarly to you do. You know, text versus video, time of day, difficulty level, et cetera, et cetera. So they have very similar learning styles. They can probably communicate very effectively with you. And then we can figure out, well, you know, breakage is usually about 80%, so 20% will actually respond if we ask them the question, and then we ask 15 people a question, we get 3 responses, and boom, inside of a minute, you get 3 awesome responses, right? So what Newton is trying to do is find very scalable solutions to kind of persistent education problems, because anybody can solve tough education problems if they, you know, bleed resources and human time and get, you know, lots of tutors for everybody. The really hard thing to do is get scalable solutions. Our scalable solutions are, we've got this algorithm that can use all of your past data and everybody else's data to find the optimal homework for you every day and build literally a unique textbook that is custom designed for you every day, right? And by everybody else's data, I mean if 100,000 people or 10 million people have learned rules of exponents the day before you learn it, we're going to go query that entire database, and we're going to ask who learned rules of exponents the very best, who's a lot like you, has a similar learning style, had a similar concept mastery profile. Let's take the combined power of that entire network of 10 million people and use it to optimize your homework every single day. That's what I mean by combining everyone's data. And then we do as much as we can algorithmically, and the next thing we can do is say, well, let's bring this intelligent tutoring to it, and then the very last thing we can do is hand the data off to the schools, and, you know, incoming professors can get, concept level, proficiency level data on all of their students.
Okay, I'm going to start with some questions, just one question and in the interest of time. Have you found a